Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abu Bakar. My metric number is 1170811. Today I want to demonstrate one of the SOAFM question. The question asks me to show that the derivative of any t immediate respect to y is equal to negative b multiplied by any t increasing any t immediate. Firstly, to solve this question, we need to transfer the unity immediate to 1 minus 1 plus I to the power of negative n divided by I. Then, after we transform this, we need to differentiate this equation. So, to differentiate this equation, we need to apply quotient rule. After we solve the quotient rule and differentiate this equation, we get the answer from deriving unity immediate to respect to I. This is not the final answer. We need to transform this equation to this. So to transform equation this to this, we need to have algebra skill. And firstly, we know that beside of this equation there is 1. So we need to change 1 to 1 over I divided by 1 over I. Then we will get the solution like this. There is I in this equation. There is I. So we will get and 1 plus I 1 minus 1 plus I to the power of n divided by I. So now we know that this is unity immediate. So we need to transform this to unity due, because in the increasing unity there is unity due in this side. So we need to multiply this term, this equation, with 1 over 1 plus I divided by 1 over 1 plus I. So and after we multiply this equation with 1 over 1 plus I divided by 1 over 1 plus I, we get this equation. After we get this equation, we need to first, before we transform this equation to more simply, so we need to know that first I over 1 plus I is equal to D. Then 1 over I to the power of negative 1 is equal to V. 1 over I to the power of negative n equals to Vn, and 1 over I equal 1 over I to the power of negative n minus 1 is equal to V and V. So then we change this equation according to the statement that we get, and this return be like this: V and V multiplied by V. Okay, we know that this is will be like this, and this divided by I. Okay, we from this equation we can see this term can be unity duos, and then there is V in this side and in this side, so we can factorize this. Equal to V and Vn minus unity 2 divided by I. Okay, so we know that from the formula of increasing unity immediate, there is unity due in this side and Vn in this side. So we need to change this, and the sign is for unity immediate is positive and Vn is negative. So we need to multiply this by negative in this inside of the bracket and outside of the bracket. So negative B, we expand this and we return be like this. Okay, now we have this. So it is increasing unity immediate equation. So we have negative B multiplied increasing unity immediate. Okay, there is proof. Okay, moving to the next question. Find expression for the derivative for any continuous unity in respect to n and continuous accumulated value for unity, continuous unity respect to n. So this is a present value and this is accumulated value. Okay, then we need first we find this d over dn a and a. Okay, we know that the present value for continuous unity can be turn out be like this. Delta. Right. Okay. After we get this, we modify this equation to be like this because it want to differentiate this equation respect to n. So we need to modify this equation to more simple equation that we can be derived. So we simplify this equation to be like this. Alright. Okay. Now we differentiate this equation. So we know that we want to differentiate equation respect to n. So we turn this to e ln 1 plus I to the power of n divided by delta. Okay, so it very make us more conveniently to solve this solution. After we get this equation, we differentiate this equation. Okay, this will be turned out to 0, and this will be like this. Okay. Okay. Now we can simplify this equation to more conveniently. Okay. Okay, we differentiate this equation and we get like this. Alright. Okay, we know that delta is equal to ln 1 plus I. So multiply by this equation okay. We can cancel out this and this. So we will get 1 plus I to the power of negative n and equal to Vn. So we know that derivative for present value continuous unity, we will get Vn. Okay, now we want to solve for the accumulated value for continuous unity. Okay, we know that formula for accumulated value for continuous unity, we will get like this. By delta. Alright, the same method, almost the same. Okay, after we get this equation, we simplify this equation to more conveniently for us to derive 1 plus I to the power of n delta minus 1 over delta. Okay, when we get this equation, when we get this equation, we differentiate this by with respect to n. So we differentiate this equation. 1 over delta, we need to transform this first to e ln 1 plus I over 1 plus I to the power of n, because it will make us more conveniently to solve this equation, because the variable is power. It is not in the equation, like it is power, so it's very difficult for us to solve, to differentiate like normally. So we need to transform it to e ln 1 plus I to the power of n. So when we get like this, we will get like this. Alright, after we get like this, we need to simplify this equation. And we differentiate this, and we get ln 1 plus I, and we know that delta is ln 1 plus I. I'm sorry. So okay, after we get this equation, okay, it is same like this, so we can cancel out, and the final answer we will get 1 plus I to the power of n. Oh, now we can conclude it. The differentiate for derivative for present value continuous unity respect to n, we will get Vn. Why? The differentiate for accumulated value continuous unity, we will get 1 plus I to the power of n. So okay, I'm done. So thank you.